changes in the climate are widespread, they're rapid, they're intensifying, and they're unprecedented. And we certainly see that when we look. This figure here on the left is showing you the Greenland air sheet. Loss of ice from Greenland and Antarctica. The ice sheet contribution to global average sea level rise has grown substantially from about a tenth of a millimeter per year over the 1990s to about a global story at a scale where we have to make decisions about how to adapt to sea level rise. A variety of factors complicate the sea level rise picture. This includes things like ocean winds and currents, which move water around, the gravitational effect of moving water and ice. So as we move these large masses of ice, say from the ice sheets into the ocean, that changes the Earth's gravitational field and tugs water around in different ways, changing sea level. And the sinking and rising of land, which can be due both to natural factors like plate tectonics or the ongoing response of the land to the end of the last ice age, like pumping groundwater or pumping hydrocarbons, or the loading of land under buildings. And these factors are pictured here in these two maps, which show from satellites the change in the height of the sea surface from 1992 to 2021, and this is primarily showing you the effects of changing ocean winds and currents over this time period, as well as long-term trends and subsidence and sinking of the land. So these areas with these deep red colors are having particularly rapid sinking of the land, which leads to effectively a relative sea level rise in those areas. Now, sea levels rising has pretty direct impacts on coastal hazards. Higher sea levels lead to more frequent and extensive flooding. So high tide flooding becomes more frequent, and when we get storm surge, it comes on top of a higher average sea level and thus leads to more extensive and damaging flooding. Here we can see tidal flooding pictured in two examples, one on the left from the Philippines and one on the right from New Jersey in the United States. Globally, high tide flooding was more than 60% more frequent over 1995 to 2014 than over 1960. And their ultimate scale reduced by global temperature. So sea level rise is going to continue for many centuries to come, creating an escalating hazard for coastal communities. This figure here on the left is showing you the projections of sea level rise from the Sixth Assessment Report through the year 2100, including 5 different emission scenarios, ranging from those featuring sustained growth of emissions at the top to those featuring at the bottom rapid emissions reductions consistent with the 1.5 degree C target, as well as an indicative storyline showing what might happen at the high end if ice sheet instabilities that are currently poorly constrained by the scientific research come into effect. So most likely, through 2100, we are looking in this range from about 0.5 meter to 1 meter, but we cannot rule out sea level rise globally approaching 2 meters if we are in a higher emission scenario and some of these poorly constrained ice sheet and a vast majority of the world's regions are projected as a consequence to experience an increase in coastal flooding throughout the 21st century. Throughout the middle of the century, sea level projections exhibit limited sensitivity to emissions. What that means is that there's a substantial amount of sea level rise already baked in, regardless of how quickly we bring our emissions down. In particular, relative to 1995 to 2014, the likely global average sea level rise by 2050 is about 15 to 30 centimeters, regardless of emissions reductions, where we're using likely in the technical Ipcc sense to mean at least a 2 in 3 chance that it'll fall in this 15 to 30 centimeters. And as a consequence, that means that extreme sea levels that occurred once per century in the recent past will occur about 20 to 30 times more frequently by 2050. So colloquially, we might say that the 100-year high water level is likely to become, on average around the world, about a 3 to 5 year high water level. Beyond 2050, sea level projections are increasingly sensitive to emissions. The likely global mean sea level rise by 2100 is about 60 to 90 centimeters under high emission scenarios, about 30 to 60 centimeters under a low emissions scenario consistent with limiting warming to well below 2 degrees C. By 2150, these differences grow to about 1 to 2 meters under a high emission scenario, about 0.5 meter to 1 meter under a low emissions scenario. What's more, the more we limit our emissions, the lower the chance we trigger instabilities in the polar ice sheets that could substantially increase sea level rise. Global mean sea level rise above the likely range, which could approach 2 meters by 2100 and 5 meters by 2150 under very high greenhouse gas emission scenarios, cannot be ruled out based on our current understanding of ice sheet physics. higher global mean sea level rise before 2100 could be caused by earlier than projected disintegration of marine ice shelves and the abrupt widespread onset of instabilities around Antarctica, or faster than projected changes in the surface mass balance, that is, basically how much melting we get from Greenland and discharge from Greenland. In the longer term, sea level is committed to rise for centuries to millennia. This figure here on the right is showing you, for different levels of peak global warming, the expected amount of sea level rise on a 100-year timescale, on a 2,000-year timescale, and on a 10,000-year timescale, compared to what we see during two recent geologically past warm periods. The last interglacial, over down here, where we have about 5 to 10 meters of sea level rise, and the mid-Pliocene warm period, about 3 million years ago, where we have about 5 to 25 meters. In summary, over the next 2,000 see, with 3 degrees C warming under a 2,000-year projection, we see flooding up to the steps of the Abul al-Bas al-Mursi Mosque in Alexandria. So another way of thinking about this is that even though there are multiple meters of sea level rise eventually in the pipeline, limiting emissions slows sea level rise and allows more time for adaptation. Considering only processes that are relatively well constrained, so not these instability processes that might lead to greater sea level rise, global mean sea level rise is likely to exceed half a meter between about 2080 to 2170 under low emissions, and between about 2070 to 2090 under very high emissions. And this is pictured here on the right, where these bars show the likely range of when global sea level rise will exceed half a meter under a suite of different emission scenarios. It is likely to exceed 1 meter between about 2150 and after 2300 under low emissions, and between about 2100 and 2150 under very high emissions. But when we consider some of these ice sheet instability processes as well, under very high emissions, we could be looking at 1 meter by about 2080 and 2 meters by about 2110. But again, that's taking into account the possibility of both high and very high emissions, some of these ice sheet processes that are still on the frontier of science right now kicking in. Something you might want to consider if you're doing a risk analysis for something where it would be very bad if we end up in that world, is a low likelihood or unknown likelihood outcome contingent particularly on high emissions. Now, most of what I've shown you are projections at a global scale. But behind all of these are regional projections. And one of the new things we've done in the sixth assessment report, these projections available to users through an easy interface. So in a partnership between the Ipcc and the NASA Sea Level Change Team, we've developed the Ipcc NASA Sea Level Rise Viewer, shown here. If you go to sealevel.nasa.gov/Ipcc, you can find it, and you can pull up for anywhere around the world figures corresponding to those shown in the sixth assessment report for global sea level for local sea level change. So for here, for example, we're looking at projections of relative sea level change in Alexandria under a couple of different emission scenarios, plus the possibility of factoring in the ice sheet instabilities, as well as when 1 meter of sea level rise will be exceeded under a suite of emission scenarios. So if, for instance, 1 meter is particularly salient because it leads to overtopping of flood defenses, that might be an important figure for you to look at. So thank you for listening to this talk, and I'm now going to hand it over to my colleagues.
Can you hear me? Okay. Hi, everybody. Welcome, and thank you so much for coming to our event. We've gotten off to a rocky start, but hopefully you can learn some things about sea level rise. I'm Sarah Cooley. I'm the coordinating lead author for Chapter 3 of Working Group 2 report on oceans, marine ecosystems and their services. And I'll be telling you what our team worked on the sea level rise content for this Working Group 2 report. So I'll be talking mostly about the impacts of sea level rise, vulnerability, and adaptation to it. Thanks. So there's high confidence that continued and accelerating sea level rise is going to encroach on coastal settlements and coastal infrastructure. And we also have medium confidence that it will commit low-lying coastal ecosystems to submergence and convenient figure showing how the mean sea level and then monthly or yearly or decadal events on top of that would affect sea level rise or overall water level. And on the right, you can see how all of those events overlaid on a rising mean sea level really overtop most coastal areas' customary levels of inundation. So there are a number of ways that communities respond to ongoing sea level rise and land subsidence. They can include protection, accommodation, advance, and planned relocation. No response is shown up on the left, where you leave your infrastructure in place and it gets flooded. Advancing means really kind of building forward and up towards the water's edge. Protection is something we're all familiar with, seawalls. Retreat is also something that's pretty familiar, moving assets away from the high level. Accommodation is something, building your infrastructure up on stilts. And then there's ecosystem-based measures, which can use tidal ecosystems to help buffer the effects of those storm waves and the rising sea levels. So these responses to sea level are much more effective if they're combined and sequenced and planned well ahead. They need to be aligned with the values of the communities where these measures will be taking place and with the development priorities of those communities as well. And one way to help do that is to make sure that the measures are underpinned by inclusive processes that really engage large portions of the community in deciding what future the community wants together and how they want to respond to this challenge together. So this figure is something that we worked on while developing the summary for policymakers. And the idea here is to really underscore this idea that societal actions and choices that happen in the next decade are going to determine the extent to which medium and long-term pathways can deliver higher or lower climate resilient development. So this figure really indicates how retreat and accommodation are measures that are often taken in the early times of sea level rise, and then protection and advance are things that are sort of later or more layered activities that can go on. One of the most urgent challenges that communities are dealing with right now is chronic flooding and high tide. We hear about this a lot in the United States, about Miami and the areas around Florida. We hear a lot about it in Europe around Venice, where high tides bring high water, and then on top of that, the water is just encroaching on the land. And so what we're seeing is things like, high tide flooding is twice as frequently in 2000. It's going to be up to 75 days a year in 2050, according to some numbers by NOAA in the United States. And you can imagine this is going to profoundly change the way that communities along the coasts go about their business. We also assess that coastal wetlands help protect against coastal erosion and flooding. The challenge here is to ensure that coastal wetlands have sufficient space to move upland. Coastal wetlands will move upland gradually over time. However, a lot of times they will bump into human infrastructure, which I'll show in a second. So until rates of sea level rise actually overtop the natural adaptive capacity of those coastal ecosystems to build sediment or shift upstream, coastal wetlands can be a really good measure. So one of the things that is a challenge here, though, as I mentioned, with built infrastructure, seawalls, things like that, to kind of slow the advance of sea level rise. A lot of times, hard defenses against flooding can really challenge biodiversity because hard defenses reduce space for natural processes. They can degrade, disrupt, really interrupt ecosystem functioning and reduce coastal ecosystems' resilience to climate change. And so this also reduces these ecosystems' ability to provide ecosystem services. And so hard defenses can be a severe form of maladaptation. This is kind of a classic example of a seawall, but something like this is also a hard defense that can do the same, have the same disruptive effect on ecosystems. We have a number of reasons of concern around meters of sea level rise. There are many, many communities around the world living in low-lying coastal areas. This is really an existential threat for small island states. It is also a massive threat for long-living infrastructure like energy, transportation, ports, coastal cities. Something we think maybe less often about is the effect of sea level rise on cultural heritage, landfills, industrial sites near coasts, and then certainly unique coastal ecosystems. There's high confidence that these adaptation challenges are going to occur much earlier under the high rates of sea level rise, especially if we have these low likelihood, high impact outcomes associating with collapsing ice sheets. So adaptation capacity and governance to manage risks from projected sea level rise require decades to implement and institutionalize. This is kind of, your common sense intuition, but it's also borne out by the evidence. And this figure is a really interesting one when you sit with it a little bit. It's from the cross-chapter box on sea level rise in Working Group 2, and it really focuses on the idea that certain measures take a certain amount of time to plan and implement. They're also good over a certain lifetime, but you can see that there are different sort of tiers of effectiveness. Ecosystem-based adaptation has a short timeline to plan and implement. It also has a relatively short effectiveness against the projected amounts of sea level rise. Something like planned relocation takes a lot longer to plan and implement, but it is also effective for a longer lifetime. So consideration of how all of these measures interact with each other and interact with community goals is a key piece of planning. So the future of the coasts depends on our immediate mitigation and adaptation actions. There's a very clear theme coming out of the evidence from Working Group 2 that mitigation will help, in this case, limit sea level rise rates and give a lot of more time for adaptation and to preserve those resilient ecosystems. Adaptation to some of the committed impacts of sea level rise is also really necessary. So we're going to be looking for measures to adapt to things like flooding and erosion and salinization of groundwater. But adaptation and mitigation need to happen hand in hand so that the broadest portfolio of measures can be maintained. And then when we're implementing climate policies, we can actually create more resilient coastal environments by thinking about multiple goals and outcomes and problems at the same time. And this graphic is actually a snippet from the Summary for Policymakers, where it really looks at the relationship of measures against sea level rise, like coastal defense and integrated coastal zone management, with how they relate to the Sustainable Development Goals on the right, and also the relationship with high-risk sectors and groups. And with that, I will stop because we are running a little bit late. To keep some time for question and answer, I would like to thank you for your time. And Saiful and Karina and I will be here for question and answer, and we will attempt to take questions also that can be answered by our team of experts online. But first, hang on, don't get too crazy. We also have some information on a policy brief. I don't know if I have the text for that at my hands right now. So I would say let's do some Q&A, and then I will present the policy brief if we cannot get our policy brief presenters audio. Okay? Can you do some mediation or some moderation, and I will get the text for the slides. Thanks. Thanks for your attention, everyone. Yeah, you just get up there and ask for questions and all. Do we have any questions from the audience? Well, we can start with room questions if we can.
Hi, a question.
Oh, shoot.
Hello.
Excellent. A question?
Thank you. When those different scenarios are looked at, how do they take into account the variability of possible methane and carbon dioxide release from the permafrost?
Okay, that's a question for working group 1. I think the question was how are methane and permafrost emissions taken into account in the emissions projections?
Okay, can I switch to virtual?
Oh boy, I don't know. Good question. I don't have the people up.
Oh no.
I don't know where they are.
Okay.
I don't know where people went. I think they're following along on YouTube.
Is there virtual colleagues out there?
Yeah, we don't have them on the StreamYard anymore.
Oh, we don't have them?
They've disappeared. Our virtual panelists have disappeared. Let me scoop out of the way.
Okay. Just hold on. No. Okay.
We will tell you.
I think there is technical difficulty. Anyway, okay. They can hear us.
Okay, yeah, Bob is going to answer the question, and then you can repeat the
Oh,
answer.
okay.
Got that?
Okay. Got that. Thank you. Okay. Yeah, I just respond from my end before our is working. Okay, I got his response. The different emission scenarios reflect a range of emission feedbacks, make the higher emission scenario more likely than you would expect based on the human emission only. I mean, the permafrost thawing will release CO2 and methane more, and the higher scenarios will more likely to cause more release and more instability. Any other question and comments?
Oh, he had an additional piece to that. He said, so if our emissions are closest to a moderate scenario, we might want to also look at a slightly higher scenario to take those positive feedbacks into account. Yes, we have another question from the audience. Please, go ahead. Not really. Can you turn up levels? Maybe just walk up and ask the question. Come on up.
Yes.
I mean,
yes.
I can hear you because you're walking closer to the podium.
Yeah.
Go for it.
Okay, as you showed, and we all know this, a lot of adaptation measures, huge investments, and they're effective over long time scales. Do you have any thoughts on evaluation of the effectiveness of those measures? Because that's something that comes up always in the discussion. But how do we know we need this? Because it's a lot of money, it's 10 years of investment.
Mm-hmm.
Thank you.
That's a great question. Do you want to? Yeah. Okay. Did anybody? Let's see. I'm going to ask my team here, my virtual team, if they can weigh in. We have an answer coming in from Rajaline, who she's asked to repeat the question. The question was, to the best of my ability, because of the incredible cost associated with a lot of these adaptation measures, what are our options for kind of getting them going ahead of time or early enough? Was that the heart of your question, sir? Pardon me?
Maybe not completely.
Oh.
I was wondering how to evaluate
Oh, how to
the
evaluate.
effectiveness of the measure.
Okay, got it.
You would implement the measure and then say, years we're going to
Right.
whether that worked. This
Right.
is not helpful with policymakers.
How do we evaluate on a shorter cycle?
Exactly.
Uh-huh,
Something
okay.
that will only be effective in a very long time scale.
Right, right,
Thinking about policymakers and the need to take decisions on
right, right. I think you know, from where I sit, the coastal, it's a great question because coastal measures that are implemented as adaptations for really any ocean-based climate impact, a lot of times they're put in place and they are not. Okay, where our people on YouTube have lost the room, so they're not with us anymore.
Can I add on that?
Yep.
Yeah, some country
Oh.
like I can tell respond from Bangladesh. We recently make Bangladesh Delta Plan 2100 in the support of Netherlands governments, and the plan is such that is adaptive delta management. So we are doing phase by phase instead of regret after back. So some plans are like if you don't put all the money and, together instead of do the delta and adaptation by phase. That in Bangladesh is planning in the for the mitigate the challenge of the next century. Thank you.
That's something that our colleague Marjolaine has also said. Adaptation can be staged over time and evaluated against a large set of scenarios. For example, using an adaptation pathways approach. But what I was going to get at was the idea that a lot of times adaptations are put in place to respond to one challenge, but they're really helpful for other problems as well. For example, coastal, nature-based coastal solutions are really good to maintain biodiversity and help support livelihoods. And they're also really helpful against sea level rise when they're, in particular configurations. So really kind of thinking early on about the basket of adaptations and benefits that any particular adaptation has, and then tracking those over time is an important piece. A lot of times that's not done at the beginning of a project. For example, coastal restoration is done for biodiversity enhancement, period. And that's all that it's tracked for. But we can rethink how we do that a little bit, and we can get better at recognizing the benefits over time. Do we have additional? Yes, ma'am.
It's not a technical science question, but more about communications.
Mhm.
So in Australia this year we've had 3 1-in-3-year floods. How do we change the language you're using? And it kind of goes to that other gentleman's question, because how do we persuade policymakers and others, other than giving us wonderful drafts that we all get to understand, but they look at it.
Right.
So how do our communications both influence there, but also the people on the front line of the coasts and rivers
Right.
and so on? How do we change the thinking? This is not a one-and-a-half. This is how we now have to
Right.
adapt to a future that is upon us.
Right. I think one of the things that's really effective is our figures, kind of like what I showed, where it's like, here was what the 100-year flood was. Now with sea level rise plus the decadal flood, you're getting 100-year floods. So I mean, communications that kind of say what you used to think of as a 100-year flood is now a 1-in-10-year flood. There needs to be that sort of bridging step, but I think that's actually a pretty effective measure. I'm actually hearing a lot of those sorts of messages come out in the United States, and it is getting people's heads nodding, and it's getting people thinking. So I do think there needs to be kind of a concerted push towards kind of saying like, that was then, this is now. We're seeing a lot of the similar conversations in the natural hazards community when it comes to storm strength. Do our storm ratings, are our storm ratings effective enough, or do we need to be, kind of thinking about that? Yeah. Do we have additional questions from yes?
Yes.
Oh, wait for the mic, I think.
It's a very important question.
Yes. Hello. Thank you for your presentation. It was very interesting, and also for the land that I come from. In Chile, we have a very difficult issue now with relocation and desertification, but also the rise of the level of the sea.
Mhm.
And I have a question for traditions of the people,
Mm.
because I don't know if they're taken care of, and I think it's a reason in which some projects like this could fail, like in the town where I was born. People are fishermen on the beach,
Right.
and now we don't have beach because of the rising sea level. And they don't want to move, but their style of their form of life it's vanished, and it can't be done anymore.
Mhm.
So I'm trying to understand how adaptation in these cases uh, can be understood by people that don't want to change their way of life,
Mhm.
and are not concerned about climate change, and in
Mhm.
some cases don't understand what is happening. It's
Okay.
also in Chile this part for indigenous people
Mhm.
and fishermen that have very low quality of education in this region.
Mhm. Okay.
So
Yeah, thank you for
that's
that
it.
question. I mean, really, the question of how do we conduct adaptation and relocation, if necessary, in a way that's just and equitable, is a really hard question. That's why the evidence really suggests that one of the best ways is that communities need to co-develop solutions. So we need to have members of the fishing community at the table. We need to have members of indigenous communities at the table making decisions along with, national or regional decision makers. There is no one adaptation decision that is a one size fits all solution. Every community is going to have its particular needs and concerns and goals. And so all of those interests need to be represented so that solutions can be developed that are appropriate and equitable for communities. In a lot of communities around the world, indigenous communities are at the front lines of getting hit by climate change and needing to adapt, and they're fully aware that their traditional ways of interacting with their environment are not quite intact. But the solutions are going to look different for each group around the world. So that inclusion step is really important. I also have members of my team pinging me, and they're also reminding me to mention that we need to have different awareness of different impacts of climate change at every level. So, for example, fishermen may be experiencing changes in fisheries, but they don't know that it's climate driven. They might be like, oh, the fish have been gone for a decade. I don't know why. And then also we need to align these plans to adapt and to create these inclusive adaptation plans with overall socioeconomic development. We can't solve for climate change while ignoring human development. We have to solve for all of these problems at once. Thank you for that question.
I think relocation is the last option, probably.
Absolutely, absolutely. It's
Okay.
it's incredibly disruptive,
Yeah.
and but there will be inevitable places where relocation must happen.
Yes.
Do we have other questions from the room? Yes,
Yes.
sir.
I have a question about relocation, actually.
Okay.
So there are places where you can just live with below the sea level line, like in the Netherlands, but there are places in Florida where you just can't because of the geology. So what fraction of coastal communities around the world are physically protectable with walls, would you say?
That is an excellent question, which I am not equipped to answer. I'm seeing that somebody on my channel is typing, so stand by. Stand by. Well, the question for the folks on the oh man, it's a race. There's two people typing.
But Netherlands coast is protected, right?
It's an unusual case, I think. There are studies assessing where it is economically efficient to protect instead of relocate. I don't know, and that's true in basically all urbanized areas. We're seeing a lot of discussion about how to protect big cities, cities by the sea. We have a Cities by the Sea cross-chapter paper in Working Group 2 report, and so you might find that interesting.
Also in Bangladesh, we are raising our embankment heights because of change of sea level rise. So many countries are doing that.
Yep.
We get some.
And we have the point is that the building a lot of the engineered adaptation, and so that does have harmful impacts on ecosystems.
But we
So
also
trade-offs.
we also do nature-based solutions. In our country, we are doing mangrove afforestation in front of the dikes. So it's a combination of both because we don't want it to also disrupt it with maladaptation practice to the ecosystem.
Yeah, we have a statistic coming in here saying that at 1.5 meters, we have an increase of about 20% of the population at risk of a 100-year flood, and this doubles at 0.75 meters. So quite a lot of people at the front lines. Thank you. Did I see another question? Yes.
Hello. So in terms of like messaging, going back to that, a lot of people when they see these projections get very scared, and sometimes even policymakers will kind of give up hope or just kind of turn a blind eye because they think it's unfixable. Would you have any advice about sort of conveying this to policymakers and people who actually make change in a way that is effective and will get them to understand the problem?
I think personal stories are amazingly effective with policymakers. Knowing that there is a problem that is here now and it is happening to real people with names and homes and families and traditions is incredibly powerful. If you can get those people to stand up and say, I'm here and I need a solution, that is doubly powerful. Would you like to bump in here? Come up and grab the mic.
Thanks for this question. Thanks for this question. So I would like to add for this messaging that, for example, Working Group 2 has assessed a lot of solution options as well. So in terms, for example, for adaptation. And I think something which would be really important is to assure that the solutions and the options are really communicated and brought in line with the messages of the change which is actually happening and is projected to happen. So I think opening up the options is a very important part and should be included in this messaging.
Thank you.
Thank you. Other questions from the room? Yes.
Question for Bangladesh, if I may.
Yeah.
What percentage of the silt that comes down in rivers over your country is captured where it would be useful to counter sea level rise? You build up the land as the sea rises. Where I live in Hong Kong, there's an awful lot of silt that just goes straight out to sea.
Okay. I responded directly because it's on my country. We are right now doing coastal adaptation with the dikes, but we did not capture this natural sedimentation because it's a delta is progressing naturally. But there are some initiative with making cross dikes, cross dams, very few. But because its delta is progressing slowly, so natural sedimentation come and it actually interacts with sea level rise. And hopefully we might not receive that amount of sea level rise threat if we get more and more sedimentation. Thanks.
Thank you. And one thing I want to note, I've got a note coming in from one of our remote panelists, and they're also really pointing out that the timing is really important of any of these responses. So when we're talking about sea level rise, it's like 2 meters of sea level rise will happen, but whether it takes 150 years or 1,000 years, it depends on mitigation reduction. So we need to make sure that those emissions are reduced. And so that's a powerful message to policymakers. Do you want all of your constituents flooded out, in 100 years, or do you just want to like some of them? I mean, that's kind of a dark way to think about it, but like really talking about those timelines matters with sea level rise, because those timelines are the things that we can adjust with mitigation, and those are the things that really give us more time to prepare.
I just like to add one thing. I should, because we are also subsiding delta. Because of the dike, delta is subsiding. So that's another countermeasure. So
That's right. That's right. Any more questions from the crowd here? All right. I think we'll probably end this. Thank you so much for your attention. Thank you for your patience with our technical difficulties. We're the first event, so we are bound to have bad luck. So
Thank you.
appreciate your patience. Thank you.
thank you, really.
So thank you guys so much for attending our event. And like Sarah said, thank you for understanding our technical difficulties and